therefore, one molecule of methane contains one carbon atom and 4 hydrogen atoms. So let's find the molar mass of each atom according to the periodic table. Well, the atomic molar mass of carbon that is 12.01 grams per mole. The atomic molar mass of hydrogen that's 1.01 grams per mole. So to calculate the molar mass of methane, we need to add up the molar mass of all of the carbons and all of the hydrogens involved. And so the molar mass of methane is going to be equal to the atomic molar mass of carbon plus 4 times the atomic molar mass of hydrogen, because we have 4 hydrogens involved. So we have 1 carbon plus 4 hydrogens, so this is our equation. So that should end up being 12.01 grams per mole plus 4 times 1.01 grams per mole, which should equal out to be 16.05 grams per mole. So this is the molar mass of methane. Now we can use the molar mass of the substance in a number of different ways, but primarily, oftentimes you'll need to find either the actual quantity of matter in grams, or the actual mass of a substance, once you've been given the number of moles, or vice versa, where you need to find the number of moles based on the mass that you're given. And so by using the molar mass, we can relate these two concepts. So a basic equation is M is equal to N multiplied by capital N. So this is where M, little m, is the quantity of matter or we can say the mass in grams. N is the number of moles. And capital M is the molar mass. So for example, if you're given a chemical equation and you need to establish how many grams of one substance will react with how many grams of another substance so that there is none left over, you need to be able to utilize the molar mass and the number of moles. So for example, suppose that I want to find the mass of 3 moles of carbon. So what I can do is I can use what's called either the factor label method, or it can also be called the unit conversion method. And so this is a conversion from moles to mass if I'm trying to find the mass of 3 moles of carbon. So first of all, I'm going to write the equation I know that relates mass to moles. So that's the mass is equal to the number of moles multiplied by the molar mass. So we're going to choose a ratio above that has the moles in the denominator in order to find the mass of carbon found in 3 moles. So we are solving for mass, so we don't need to rearrange this equation at all. So what we're trying to find is the mass of carbon is equal to the number of moles, which we know is 3 moles, multiplied by the molar mass of carbon. Now the molar mass of carbon, we already know, we're just looking at carbon itself, so we can just take a look at the periodic table, and we find that the molar mass is 12.01 grams per 1 mole. Right? Now typically we write it as 12.01 grams per mole, but this is the same way of writing it. Now, in order to use our unit conversion method, it's important that we write them as sort of fractions like this. So I'm going to put, because moles is in the denominator, it's grams per mole, I'm going to say it's the same thing as 12.01 grams per 1 mole. So I'm going to write it as a fraction like this, and we'll see why in a moment. Because as we're trying to convert to find the mass of carbon here, what's really helpful in using this method is we can get rid of the units that we don't want. So we know that for mass we want grams, right? So mass, we want grams. So what we're trying to do is get rid of the other units. And so as you can see, as I take a look at this equation, I have moles on the top and moles on the bottom. So what we can say is that these cancel out. What that leaves us with is the mass of carbon is equal to 3 multiplied by 12.01 grams. And that gives me 36.03 grams. So in 3 moles of carbon, there's 36.03 grams. Now let's take a look at a different example where we're trying to find the moles after being given the mass. So again, let's take a look at our equation. So our equation is the mass is equal to the number of moles multiplied by the molar mass. Now if we're trying to find the number of moles, well, we can rearrange in order to find n. So n is equal to little m over big M. So mass over molar mass. So what we can do instead is we can take a look at 1 mole of silicon. So that's the molar mass of silicon is 28.09 grams per mole. Now we can write that as either 28.09 grams over 1 mole, because that's just per 1 mole, or we can actually write that as 1 mole of silicon, so this is silicon we're talking about, is 28.09 grams. So we can use these ratios in order to help us, like we did earlier, cancel out the units that we don't want. So if we're looking at this example where we're given the mass of silicon, which is 56.18 grams, well, what we want to do is we want to choose one of these ratios that's going to help us get rid of grams. We're trying to find the number of moles, right? So n is equal to, we're trying to find the number of moles. So we want to get rid of grams and have moles instead. So in order to get rid of grams, I have grams on the bottom. So that looks like this ratio right here. So what I can do is I can take the mass and I can multiply it by this ratio. 1 mole of silicon is 28.09 grams. Here my grams are going to cancel out and I'm going to be left with just moles of silicon. And my answer is going to be 56.18 moles of silicon over 28.09. And now I can just simply divide and I find that my answer is 2.000 moles of silicon. And this is, like I said, using that unit conversion method, which will be very helpful in later questions.